So I first learned about doing this presentation in a meeting with my peers, and a buzz instantly went around the room, and it went along the lines of, oh my God, it's the Stack guys on a night out, fueled by alcohol, they're server ninjas. There was a sound of clattering furniture and swinging doors, and my manager said, oh, Andy, a volunteer, fantastic. And he said, just one thing. He said, these guys are fixated with latency. He said, you remember that? So, it's all right, boys, you're in good company. I always arrive first as well. So, we'll crack on. So, this is what you could have had. All right, so we could tweak the living daylights out of a server, and I could show you some really boring graphs. But I chose option 2, which was talk about something that hopefully you'll find interesting as well, and it will have some relevance to your subject matter as well. So I'm going to talk about innovation, and innovation is new ways of leveraging, my God, I sounded American there for a minute, existing ideas and technologies, but putting them together in a way that creates different value. And an invention is a completely new, it's like that aha moment kind of thing. And in HP, we consider both. After all, HP invents. We do, don't we? Or at least, that's what we're meant to do, and bring that to the marketplace. That logo, by the way, is a very old one, and it caused, allegedly, the largest corporate migration in history, because people think that when you invent things, it's exciting, it's new, and it's a really cool place to be. And hopefully by the end of this, you'll agree that we are still doing some cool things, even though we typically hide them under a bush now. So I'd like to quickly look back at some of the things that HP have done in the past. There's some real blinders on there. They actually patented and designed and invented the very first light-emitting diode. Now, if you've got an electronics background like me, that'll kind of warm your heart. The very first pocket calculator, the very first scientific pocket calculator, having its 40th anniversary this year. And you go and look at that thing. We've made an anniversary edition of it, and it looks and feels not dissimilar to exactly the calculator that you pick up today. A remarkable achievement. And then scooting forward, commercialized wrist chips. Everybody thought that it was Sun that brought that to market. Read-writable DVDs. We've got some really good stuff there, but what I'd like to draw your attention to is this area here. So in 1980, we invented the Office LaserJet printer. This was the best cash cow that HP invented. The sales guys that had this product were typically making $2,000 a pop on every single sale. They were all driving Ferraris. This was significant amounts of money in those days. So let me draw your attention to another one that's just next to it. In 1984, one of our geeks found a way of spitting ink onto paper. And he said, I think I can make this for about $150. And right there, you've got the innovator's dilemma. What are we going to do with this guy? Because if the Office LaserJet printer guys find out who he is, they're going to nail him. They want him buried really fast because they're about making money. And this brings you to the point of the innovator's dilemma. Okay, and it's a book that Clayton Christian wrote, and there's some references at the end, some links that I've left in the presentation, and you can go and look at this. What do we do with this? Well, the good thing to do, that in this case HP did, they ring-fenced that, they protected it from the rest of the business, fed and watered it, and it's now brought to market a $10 billion ink business. So, protected it and did the right thing. And I'm not saying that it's all love hearts and going the right way inside HP. You know, we've done some stinkers as well. We had a pet project called Kitty Hawk, and we had 2 terabyte disks the size of a matchbox. Blinding product, went absolutely nowhere. We also invented the ebook 8 years ago. Looks and feels just like a Kindle, and we never brought it to market. So we have made our mistakes as well. But, you know, we've got some good stuff too. So if you've ever changed one of those ink cartridges and you pulled it out and there's that little orange strip on the front of it that the ink squirts out of, that typically puts the red stuff on your shirt when you least need it, that's actually a really incredible piece of technology there. What it's doing, it's heating the ink up to 1,000 degrees. It's measuring exactly how much ink is in there. It's measuring the velocity that it's firing at the paper. It knows whereabouts on the printer it is. It's doing a remarkable number of jobs, and it's a tiny little thing. So we're actually furthering that development doing something called micro-electromechanical sensors. And these things will affect your world. And we're working closely with Shell to further the cause of these devices. Now, we went to a meeting with Shell and we said, we've built these little tiny sensors and we think we've got the coolest application for you that's going to save you billions of dollars. So Shell sat down and they listened, and we said, we know that you run 2 pipelines from your refineries. We also know that you have to do preventative maintenance on your pumps. Pumps that cost millions of dollars, you take out of service before their end of life because you're really scared that they're going to go wrong, and replace them with new ones. Each time that you shut that pipeline down, it costs you billions of dollars. You're at risk of your other pipeline going wrong, etc., etc. So our solution is we're going to stick these little sensors all over your pumps, and we'll be able to tell you to the day and the hour, due to vibrations and things starting to go wrong, we'll be able to tell you exactly when that pump is going to stop. And you'll be able to take it out on a preventative maintenance schedule that's going to save you millions. You'll be able to do it to the day, the hour, and then replace it with a good one and get much more longevity out of each of the pumps. And the CTO of Shell said, actually, that's great, but I've got an application that's going to save us trillions of dollars. And you kind of go, hang on a sec. And he was thinking ahead of us. Already, he's thinking of a new deployment for something that we've just produced. And he said, I do exploration by putting a sensor that costs $3,000 into the ground. I then run a wire 10 meters, I put another one into the ground, and I build a grid 10 kilometers wide. I then start putting a thumper onto the ground so that I can measure something that looks like that picture down there. I get a reflection back so I can see what the oil potential is of the ground that I'm putting this on. He said, each one of those cost me $3,000. It takes me forever to wire them up. And he said, to get the final best picture out of this, I blow the whole lot up. You kind of go, wow, quickly do the maths on that. That's $300 million he blows up to get a 10 square kilometre area. He said, why don't you put an IP address on every single one of your little sensors and make them wireless? Oh yeah, great. And then I'll be able to distribute, and you're still selling them me for $15 a go, by the way. And so there was a kind of stipulation in there. And I can now deploy millions of these things at exactly the same costs. And that's exactly what we did. So now he gets a much finer granularity of exactly what's underneath there. Deployment is literally, I'm scooping up a bucket of these things and throwing them out there. They get an IP address, they report back data, and you're good to go. And he actually leaves them in the ground. Job done, refresh the IP, they're all gone. So the longer effect of these MEMS is that you will find them inside your data centers. We'll be able to measure temperatures more accurately on machines, vibrations, fans going out of kilter. So, you know, many more applications, including experimental phase at the moment, but actually throwing them into fields, and we can already begin to determine which parts of crops have got diseases, which crops need watering, so we can save significantly more on fertilizer and produce more cost-effective food. We actually give our scientists 20% of free time, and we think that's really useful. They become innovative and they discuss things, and they start to produce things that interest them. One of our scientists, and I hate the fact that that's a bloody iPhone, but there it is, and he did use an iPhone to do this. He said, I think I can produce a 3D image from a cell phone display with no glasses in pure daylight. And he cooked up a chip, and within a month, he had floating above his iPhone, but using an external source because this thing was chewing batteries, a 2 millimeter letter X, and above it a 2 millimeter letter O. And you could walk around these things. So there it was in pure daylight. He quickly fabricated another chip, and he got a second lot of letters going, and they were 4 mil by 4 mil. And finally, he got the same letters, and they were 8 mil apiece. So in pure daylight, with no glasses, and you could walk around these things. And we showed this technology just this year at Contech, and people were queuing up to try and touch these things. Now, if you're a geek like I am, or a bit of a sci-fi fan, I kind of know what you're thinking. But isn't it funny? You look at that and you'd be really disappointed if that was the hologram that came up. You've got to admit it's lost its charm over the 30 years, and you'd expect something significantly more than that. And indeed, HP have delivered again. I talked to the scientist that did this, and he said, we've got the capability of being able to put a 1 meter disc on the floor, and we can now project a full-size human. He said, and you'd be hard pushed, really hard pushed, to determine whether or not that human is actually there. And you'd be able to walk around him. So it's already starting to push the envelope of you know, what you can do. It started up a parallel business stream as well. So we already know that 1080p and Blu-ray standards won't be enough to be able to project this image. We need a whole new mechanism of being able to capture or create, compress it, transport it, store it, process it, and then finally display this stuff. So we've actually got a parallel group now working in harmony with this continuous 3D group to be able to create and transmit this initially to a business environment, but finally to a domestic environment. And we're actually avid consumers of virtual technology ourselves. So within HP, I meet regularly in something called Teleplace, which is based on a standard called OpenQuack. And it's a room that you go in and you put headphones on and a mic, and very quickly you become immersed in this world. So there's a meeting table, and you can press a button and you all sit down at the meeting table, and you can look across. You actually use your mouse to do this, which kind of ruins the image, but eventually, so you move around, you can see, and when somebody talks, the screen goes automatically to the person that's talking. You can then gather a group of people to come across and look at a presentation that you're giving. You can leave notepads on the walls, a truly immersive experience. I had to laugh because when you first join up with this thing, the avatar, the 3D avatar that you're given, looks like it's made up of jelly beans, and you get the option to stick your face on it, and I did this, and it kind of looked like someone had painted my face on a child's balloon. So I uploaded a new module, and it allowed me to choose different characters, and I now appear inside this room as a black female called Andrea, and that's not me at the weekends, by the way. So you know, created a whole new virtual world. It freaks the hell out of them to see this white face on a black woman. But ultimately, our idea is to mold both of these together, and we're really close to this already. So creating a virtual room, and we're using something called membrane technology, where you'll be sitting opposite people that have a holographic image portrayed to you, and you can talk and hear the voices coming from them. You know, obviously, I'll appear in there looking something like that. That is actually, and obviously that's nothing like a true depiction of what I look like. There you go. That's much better. So nearer term, we have something called a Connect board. Okay, so this is a technology that we've released now, and this is kind of a stepping stone towards that. And it has something on there called gaze technology. And what it allows you to do, it looks like a window that you're looking through, and you can have visual eye contact with the person that's opposite you. So we've embedded cameras inside this. We've given a palette down the bottom there, and you can choose to pull up a Word document or you know, a PowerPoint. You can even draw on there as well. But this is where it's starting to do something clever. So you can see the guys on the other side of the glass there. He's pulled up his drawing tool, and he's decided to write on the board. He's writing high as he sees it, but it's actually projected to us so that we can read the right way round what he's writing, whilst allowing us to have direct eye contact with him as well. It also means that as you pull up a shared piece of work, you can see what the other person's looking at. You can see what that person's looking at and whether it's causing them angst. You know, you get that true collaborative experience. So that's early days. We have about 10 betas of that around the world, but we expect something very similar to be deployed in the enterprise environment quite soon. We're also working on next generation displays as well. So this is ultra thin roll-to-roll screen technology. So this is magazine quality screens, okay, manufactured on a printed roll. So you can actually roll up these screens, and I saw a guy coming off a production line, and he was carrying a roll with 1,000 screens on it, and you literally lay them out and slice them off. So uses for that, and these are ultra low energy consumption as well. We expect to be able to make them the size of a wall, so we'll be able to paste interactive walls with them. You know, it's completely changing the way that you look at what can be done with a screen. Don't expect you'll be able to fold it up and pop it in your pocket. You know, it's a once roll out, it'll sustain about 2 or 3 rolls on and off. But absolute magazine quality, gets brighter when you take it out into sunshine, and takes less than 0.09 of a watt to power it. So, you know, it's absolutely moving the dynamics of how we consume information. Our first foray with this was to work with the Department of Defense in the States, and we made a combat uniform that had a flexible screen on the arm. It went well, but having something reflective in a field of combat, there was a few teething issues there, so watch out, snipers. But you know, initial tests show that you know, it stood up robustly to the tests, and the ability to be able to embed screen technology within clothing, or indeed anywhere that you like it at an ultra low cost, has suddenly come close hand. So the final thing that I'll tell you about is something called the memristor. Okay, and this genuinely is the wheel of the 21st century. Okay, this is absolutely going to change our world. It's going to change your world significantly. Okay, the memristor was theorized by a Harvard graduate back in 1971, whose name escapes me at the moment. But he said there's a 4th component missing. There's an inductor, a resistor, a capacitor, but there's something else. And it should be a cross between like a memory and a resistor. In 2008, Stan Williams, one of our lab scientists, discovered it, and actually did some deep theory to be able to create it. In 2011, we went into pre-production with a company called Hynix. So expect this stuff to be real within 2.5 years. And what's different is we can manufacture significantly smaller than integrated circuits today. It's got the characteristics of memory and a resistor. And what's different is it takes no energy when it's at rest. So until you read or write to it, it's taking absolutely no energy, but it stores the value. So this is significant, and it also allows us to compact the size of this. And again, I met one of the scientists, and he had a hairball in his hand, and it was the size of a baseball, and it had significant amounts of wiring on it. And he said, "How much data have I got here, Andy?" And I said, "I've got no idea." He was holding 11 petabytes of data in his hand. I mean, that is just significant. He said the actual componentry, he said, once you get all the stuff away from the edge of this, he said, we expect to be able to get 11 petabytes in a sugar cube. There will be no resistance to read-write on this component. So choose whatever interface to it you want, and it will be able to go that quickly. It will keep the data for years. So fundamentally, think of it replacing, and this is a bold statement, but you will be able to replace your flash, your memory, and your hard disk with a single component. You'll be able to move it near side. It will take very little energy comparatively, and then it completely changes the dynamic of what you can do with it. So I can now put all of my VMs into memory. I can load the entire database into memory, and the data will lie at rest until I light it up. I can keep them there just in case I want it. So, you know, fundamentally changing, and all of the infrastructure around that will have to change to cope with that step change as well. How am I doing? Really badly. So HP continues to innovate. We got some really good places that show innovations. One that I will bring to your attention is called the Business Garage, and we've recently relaunched that. It's an ideation platform that's external to HP, that as an enterprise you'll be able to go onto there, submit an idea, ring fence the idea, ask if we can have collateral, IP collateral against it. So there's some places worth putting into Google and going and have a look at. So here's a last bit of lateral thinking. I thought I'd end with something of a laugh here, hopefully. So in Cupertino, October the 5th in 2011, poor Steve Jobs popped his clogs. Significantly earlier, on Mount Sinai, around 1513 BC, Moses received the stone tablets. If you're smart, you kind of know where this is going. Moses meets Steve. He's going to upgrade your tablets. So thank you very much for your time. I hope you found something of interest in there, and thanks for listening, and enjoy the evening.